Nursing 431, Measurement of Data Collection. The course learning outcomes are integrate knowledge from other disciplines when utilizing the research process and critically analyze research findings. The weekly learning outcomes include examine various methods of probability and non-probability sampling, discuss sampling errors and sampling bias, demonstrate an understanding of the concept of measurement, identify the various data collection methods, and critique selected qualitative research articles. Measurement is the process of assigning numbers to variables. There are several ways to assign these numbers, but ways are counting, ranking, and comparing objects or events. Measurement, as used in research, implies the quantification of information. Since it involves quantification, it is applied most frequently to quantitative research designs. When qualitative data are summarized and placed into categories, they lend themselves to quantification and should be included in the concept of measurement. The four levels of measurement or measurement scales are nominal, ordinal, interval, and ratio. The nominal level of measurement is the lowest level of measurement and involves the naming or categorizing objects or events. The categories must be distinct from each other and include all the possible ways of categorizing the data. Examples of nominal measurement include gender, religion, religious affiliations, marital status, and political party membership. This type of data is usually assigned a symbol 0 or 1, for example, to help in data analysis process. The ordinal level of measurement is data that can be ranked, ordered, as well as placed into categories. The exact differences between the ranks cannot be specified with this type of data. The numbers obtained from this measurement process indicate the order rather than the exact quantity of the variables. Examples of this level are mild, moderate, and severe. The interval level of measurement concerns data that not only can be placed into categories and ranked, but also the distance between the ranks can be specified. Interval data consists of real numbers. The categories in the interval data are actual numbers on a scale. Examples are body temperature or weight. The ratio level of measurement is considered the highest level of data. It includes that data that can be categorized and ranked. In addition, the distance between the ranks can be specified and a true or natural 0 point can be identified. The 0 point means that there is a total absence of the quantity of what's being measured. Examples of this level are money in a bank account or pain. When the researcher is concerned about precision of the data, the interval or ratio level of measurement should be selected. When ranked or categorized data are sufficient to use in a research study, ordinal data may be used. If categories of data are all that are needed, nominal data will be appropriate. The main considerations in determining the level of measurement for data are the level of measurement that is appropriate for the type of data that is being sought, and the degree of precision that is desired when it is possible to consider the data at more than one level of measurement. There are 5 important questions to ask when the researcher is in the process of data collecting. They are who, when, where, what, and how. You can use the acronym WWWH. So who will collect the data? This question is easy to answer if the researcher is going to collect the data. Scientific investigations frequently involve a team of researchers. Anytime there is more than one person collecting the data, assurances must be made that the data are collected in the same manner. The next question, when will the data be collected? The determination of this question will need to be made according to the month, day, hour, and so on for data collection. Also, determination has to be made for the question, how long will the data collection take? Frequently, the only way to answer this question is through a trial run of the procedure. The next question, where will the data be collected? The setting for the data collection must be carefully determined. Optimum conditions should be sought. The next question, what data will be collected? This question calls for a decision to be made about the type of data that is being sought. For example, is the study designed to measure knowledge, attitudes, or behaviors? The type of data needed to answer the research questions or to test the research hypothesis should be the main consideration in data collection. And lastly, how will the data be collected? The research instrument is important for this question. Choosing a data collection instrument is a major decision that must be made after careful consideration of possible alternatives. There are several factors that determine the data collection method. The research questions or hypothesis, the design of the study, the amount of knowledge available about the variable of interest. Several examples of data collection methods are self-report, questionnaires, interviews, physiological measures, attitude scales, psychological tests, and observational methods. Questionnaires are the most frequently reported method of data collection in nursing studies. Many research studies use a variety of data collection methods. When the various methods used give the same results, greater confidence in the study findings will occur. Great care should be taken to select the most appropriate instrument or instruments. The researcher should conduct a review of the literature on the topic of interest. When an existing instrument is used for a study, note its reliability and validity. There are a variety of sources that may be used to search for a research instrument. The Mental Measurement Yearbooks, MMY, consist of 18 volumes, with the first one published in 1938. The Instruments for Clinical Healthcare Research consist of 4 volumes and is a well-used resource for nursing research. Measurement of nursing outcomes is devoted to the measurement of client outcomes. Many of these existing instruments are copyrighted, and the holder must be contacted to obtain permission to use the instrument. If no instrument is discovered, the researcher is faced with developing a new instrument, or it may be possible to revise an existing instrument. A pilot study is conducted to pre-test the new instrument. A pilot study is a small-scale trial run of the actual research project. Factors such as time, cost, and availability of persons similar to the study subjects will determine the size of the pilot group. There are several criteria to be considered when deciding on data collection instrument. For example, practicality, reliability, and validity of the instrument. The practicality of the instrument concerns its cost and appropriateness for the study population. There are a variety of questions that may help in this process. The practicality of the instrument must be taken into account before considering the reliability and the validity of the instrument. Next is reliability. Reliability of an instrument concerns its consistency and stability. Reliability needs to be determined whether the instrument is a mechanical device, a written questionnaire, or a human observer. The degree of reliability is usually determined by the use of correlational procedures. Researchers should choose the most appropriate type of reliability for their particular study, such as stability, reliability, equivalence, reliability, or internal reliability. Lastly, the validity of an instrument concerns its ability to gather the data that it is intended to gather. The greater the validity of an instrument, the more confidence the researcher has that the instrument will obtain data that will answer the research question or test the research hypothesis. Validity may be established through a panel of experts or through an examination of the existing literature on the topic. If statistical procedures are used to obtain validity measures, they are generally correlational procedures. There are 3 types of reliability. They are stability, equivalence, and internal consistency. Stability reliability of an instrument refers to its consistency over time. When a physiological instrument is used, the researcher has to ensure that it is very stable and accurate. When a questionnaire is used, the researcher tests and retests the questionnaire over time to see if the results are almost identical. Instruments that have a high correlation coefficient, or otherwise known as high test-retest reliability, will be close to 1.00. Equivalence reliability of an instrument concerns the degree to which two different forms of an instrument obtain the same results, or two or more observers using a single instrument obtain the same results. Alternate forms reliability or parallel forms of reliability is a term used when two forms of the same instrument are compared. Inter-rater or inter-observer reliability are terms applied to the comparison of raters or observers using the same instrument. Correlational coefficients are also obtained. The higher the correlation coefficient, closer to 1.00, the more confidence the researcher can have that the two forms of the test are gathering the same information. Internal consistency reliability, or scale reliability, addresses the extent to which all items on an instrument measure the same variable. This type of reliability is appropriate when the instrument is examining one concept or construct at a time. It is concerned with sample of items used to measure the variable of interest. Internal consistency reliability is measured using split half procedure. A common type of internal consistency procedure is the coefficient alpha, or Cronbach's alpha, which provides the estimate of the reliability of all possible ways of dividing an instrument into two halves. There are four broad categories of validity to consider: face validity, content validity, criterion validity, and construct validity. Face and content validity are concerned with the instrument that is under consideration, whereas criterion and construct validity are concerned with how well the instrument under consideration compares with other measures of the variable of interest. An instrument is said to have face validity when a preliminary examination shows that it is measuring what is supposed to be measured, the variable of interest. This validity can be examined through the use of experts in the content area or the use of people who have characteristics similar to those of potential subjects. Content validity is concerned with the scope or range of items used to measure the variable. In other words, are the number and type of items adequate to measure the variable of interest? Is there adequate sampling of all possible items to get the desired data? Are the methods to determine content validity are comparing the content of the instrument with the literature, using a panel of experts who have expertise in the given subject area, developing a test blueprint design around the objective for the content being taught, and the level of knowledge that is expected. There are sources of error. I'm sorry, I didn't finish the last. Sorry. Criterion validity is concerned with the extent to which an instrument corresponds to or is correlated with some criterion measure of the variable of interest. It assesses the ability of an instrument to determine the subject's responses at the present time or to predict subject's responses in the future. The two forms of criterion validity are concurrent validity and predictive validity. Concurrent validity compares an instrument's ability to obtain a measurement of subject's behavior that is comparable to some other criterion of that behavior. Does the instrument under consideration correlate with another instrument that measures the same behavior or responses? The correlation coefficient is used to measure concurrent validity. The closer the value of the correlation coefficient to 1.00, the higher the validity of the instrument. Predictive validity is concerned with the ability of an instrument to predict behavior responses of subjects in the future. Construct validity is the most difficult validity to measure. It is concerned with the degree to which an instrument measures the construct and it is supposed to measure. A construct is a concept or abstraction created or constructed by the researcher. Construct validity involves the measurement of a variable that is not directly observable, but rather is an abstract concept derived from observable behavior. Several methods are used to measure construct validity, for example, known groups procedure and factor analysis. Known groups procedure is performed when the instrument is administered to two groups of people whose responses are expected to differ on the variable of interest. The researcher expects to find that differences occur in the scores in order to show that the instrument has construct validity. Factor analysis is a method used to identify clusters of related items on an instrument or scale. This type of procedure helps the researcher determine whether the tool is measuring only one construct or several constructs. Correlational procedures are used to determine if the items cluster together. Reliability and validity are closely associated. Both of these qualities are considered when selecting a research instrument. Reliability is considered first because reliability is a necessary condition for validity. An instrument cannot be valid unless it is reliable. However, the reliability of an instrument tells nothing about the degree of validity. An instrument can be very reliable and have a low validity correlation coefficient value. Now on to slide 13. Some error is expected to exist in the data since they are collected from human beings and the degree of control that may be placed on the research situation is limited. The errors in data collection can arise from instrument inadequacies, instrument administration biases, environmental variations during the data collection process, and lastly, temporary subject characteristics during the data collection process. When critiquing the data collection section of research reports, first try to find the section in the report in which the measurement and collection of data are reported. Next, determine if the level of measurement is appropriate to test the research hypothesis or answer the research question. Third, determine if the research instruments are described clearly and thoroughly and whether you were able to find reliability and validity information. Finally, the results of the pilot study should be reported. If not, the researcher should give some rationale for the failure to do so. You may also want to use the guidelines for critiquing the data collection procedures noted in box 12.1 in your textbook. Critiquing the data collection process, there are certain questions that you can ask yourself or look for in the article. Did the research report provide information on data collected? What data was collected? How was the data collected? Who collected the data? Where were data collected? When were data collected? Was an appropriate level of measurement used? Was there a section in which the instruments are described? Was the description of the instruments thorough? Had the instruments been used previously? Had the instruments been tested for reliability? If so, what type of reliability was assessed? Had the instruments been tested for validity? What type of validity was assessed? And lastly, was there a pilot study conducted using the instruments?